Yeah, welcome everybody, and thanks for the interest in this webinar today. My name is Philipp Thiele. I'm located in Hamburg. Started working at Giant Swarm this summer as a sales engineer. So I'm supporting the sales process on a technical point of view, giving insights to our product, for example, doing demos, also attending conferences so we can help customers answering questions on the technical side of view early in the stage of the sales process. And also I do webinars, for example, like today. What we are talking today about is how to involve your Kubernetes platform DNA. It's not that technical this time because it's somehow more cultural aspect we have to look into. But obviously we have some insights on how we do or how we have or what our DNA is handling our Kubernetes platform as well. We are talking today, or I am talking today about the insights, or just a little warm up, how the market is changing and what you have to consider in such a market. Then defining what is a Kubernetes platform DNA, talking about how platform teams can be fast and maintain stability at the same time. And obviously there is a typo there. We can support you. Obviously, we talked about this at the last part, but for the fourth part, we are talking about why platform teams struggle at the moment and what we can learn about it. All right. So before we go into the first section of this webinar, I have a little poll. Actually, I have two polls for you guys. Considering you have a platform, the question is, how often do you upgrade your platform? I will share a little poll in the chat, and I'm happy if you can answer it. And I just give a little time so you can answer it. How often do you upgrade your platform? Not only if you're in the platform team itself, but if you know how often your platform team upgrades the platform, that would be awesome. And also, we have a second one, a second poll. You can also answer this one. The second one is how often do you experience downtimes with your platform? All right. Then I go into the section. How is the market changing right now? When we see what happens in the for example, with retailers, we see that cloud native platforms are leveraging the business more and more. So when you have a good cloud native platform, for example, you are able to increase the business value because you are able to deploy faster and more often than before, and therefore can accelerate innovation. For example, when you have a retail shop, you can do tests, for example, do new features more often and more frequently than, for example, the competitors. And that's, for example, what Adidas did. They went all in on improving the digital capabilities
to improve the shopping experience for their customers, and went from 136 million US dollars to 4 billion US dollars in 2021. So they increased their revenue quite a bit. That's yes, just show us that okay, when you go or if you want to accelerate your business, you can do it by enabling or you can do it by cloud native or using cloud native, and therefore driving business value there. The other problem is with this that increasing the business value by going, for example, cloud native, you also have the risk that if you have a downtime, for example, that the business risks are higher than before. I have here a study from Gartner from 2014, which where they analyzed, okay, what is the average cost per downtime for a business actually. So they came up with an average of 336,000 US dollars per hour, and also minimum and maximum. So in this range, you can expect having costs per hour when you have a downtime. Those numbers are from 2014. When you have something like Amazon, for example, the business risk is getting really high or getting more higher than with every cloud native thing you have. So yeah, you can leverage it. You can leverage your online business, for example, or your revenue or whatever kind of business you have with cloud native. But on the other hand, you have to have the risk of downtimes, obviously, and they are costing you real money each hour you have. When we compare, when we compare, for example, the performance of cloud native, and obviously the challenge is that we have to keep the platform available with no downtimes, but at the same time we need to accelerate our time to market to enable speed of innovation. So that's that's quite a big challenge. And we have, or what we use, for example, are those DORA metrics. They're from the State of DevOps report 2021. And they show us that elite performance are statistically significantly better in having a better throughput and the stability of the platform. So we see that the industry is accelerating more and more. So what does it mean for your platform team? Obviously, is that you must handle speed and stability at the same time to enable business. So what is Kubernetes Platform DNA? Obviously, we have Kubernetes in the name. So what is Kubernetes for us? Kubernetes, the DNA, or what Kubernetes brings us is that it actually combines speed and stability at the same time. So we have, for example, the portability, that we abstract the infrastructure, for example, in deployments and stuff like that, so that we are able to deploy faster and more reliable than before. We also have the high availability characteristic of Kubernetes, so that we are able to have better availability than before. We have a high grade of automation, so that we are not error prone anymore in the processes, for example. So Kubernetes brings us this one. We have the scalability part, so we are able to react on more demand faster than before, so we can enable business there as well. And we obviously have the stability, for example, with rollback scenarios and automated health checks and stuff like that. We are able to maintain stability with Kubernetes. Obviously, Kubernetes itself doesn't bring us any production grade environments. So obviously we have to think about stuff like observability, connectivity, security, developer experience. So the developers are able to deploy, for example, by themselves as a self-service. We have the customer applications, and we have the data, and obviously we have some kind of maturity grade. Either we are only yet at the technology level where we build our platform, for example, or the operations level where we are already able to have like disaster recovery scenarios and stuff like that, and yeah, are able to evolve over the time. So all the things we need, obviously, to have a production grade platform and yeah, environment, so that we can yeah, deploy microservice applications more yeah, faster and more reliable than before. Sorry. So what defines the platform for us is that a platform is always a kind of an abstraction layer. So this one is yeah, goes hand in hand with the abstraction layer of Kubernetes, obviously. But the main goal is that when you have a developer team, that your developer teams have a paved path actually for their exercises, for their things they have to do. And the main goal is that you have, or what you should have in the DNA, is that you always have to think about, okay, how can I make the work or the task for my developers more easier than before, so that we abstract the infrastructure tasks away from them. The second one is always on. So yeah, teams can access services on demand. So there's no waiting time when I have to deploy something, when I need a cluster, dev cluster, for example, stuff like that. I always or the developer team should have access to the services on demand, so that we can accelerate yeah, software delivery. The third one is self-service. The teams can deploy and operate the application on their own. So everything they need to do for the application to yeah, be to be mature software artifact needs to be as a self-service, so there's no interaction with any kind of ticketed system or any kind of mailing in boxes or yeah, like personal contact. So it should be self-service so that the developers are able to deploy on demand, for example, and consume the services you provide with your platform via, I don't know, a self-service portal. The fourth one is actually scalability. This is yeah, something also coming from Kubernetes, or the characteristics the Kubernetes delivers us is that yeah, you should easily adding new teams without having more operational tasks than before. So the platform is yeah, scalable, and it doesn't matter how many teams you have on your platform. The yeah, work should be or should stay the same for you as a platform team. Then the last one is obviously stability, that we are able to keep our system reliable and maintainable at all times. So this is what we define as a platform. And when we talk about the Kubernetes Platform DNA, we are talking that all the things Kubernetes brings us, all the benefits Kubernetes brings us, that we yeah, embed them into our platform design. And also, when you think about your platform, the platform mindset and the mindset of the platform team should always be that the mission is to enable developer teams to innovate fast. So that's the main goal. At the end of the day, we need to deploy and deliver software faster and more often than before. So the question is, how can platform teams yeah, maintain stability and be also fast? That's it has been a challenge in the past, and Kubernetes helps us obviously with this. But how can we do this? Sorry. So the claim in organizations or actually bigger organizations might be, and I have seen a lot of organizations that have these claims, is that change approval processes lead to more stability. So the answer could be, yeah, adding new approval processes everywhere you can, so you can manage dependencies, that you can coordinate between teams, that you embed external regulations and stuff like that. But yeah, that's a claim. That's a claim, and we obviously need some kind of yeah, handling changes in production to maintain stability, obviously, because we cannot deploy something without checking if there is a dependency to different teams. For example, doing upgrades and yeah, um, and one developer team or one different part of the company sees that the cluster is down or something like that, or they cannot deploy anymore because some version conflicts are there and stuff like that. So we need to yeah, manage this risk and reduce the risk of releases, obviously, and the motivation for something like this in the IT service management, for example, is to reduce um, releases. And we have like change advisory boards, security requirements, improvement processes, and endless meetings in those kind of scenario. So yeah, to be honest, this is not the way to do it. It's a myth, actually. It's has been proven that such processes and such constructs are yeah, leading to actually leading to worse performance than before. So we have here this major issue. Why that's it? It's a separation of duties. You have, for example, I don't know, yeah, the change advisory board is a different kind of organization type, and your teams, you always have to interconnect with them, ask them if changes are right or not. And for example, security, IT security is always something you have as an extra part in, yeah, I think traditional organized organizations. So teams are not getting faster when you have this kind of setup, because you have a lot of dependencies between teams. You have loss of information, and at the end you have no shared responsibility. And at the worst or the worst, you have also like blame games and something like that. So this setup is, yeah, kind of crucial, I would say. And what we need is yeah, something more lightweight, obviously. Um, so yeah, the main problem with the picture before is that at the end, never change the running system to avoid downtimes is still the mindset. A lot of companies have, not the platform teams, for example, but when you have this culture expert or companies starting a cloud native journey, for example, or are already on the way on the cloud journey, we often hear that the platform team itself has, yeah, blockers or dependencies to other kind of organization or part of the organization. So we have a problem here. And we see that the change advisory board, for example, as a good, I think, as a good example for yeah, avoiding change and trying to maintain stability at the same time, is like that it has a negative impact on software delivery performance and also for the, yeah, feature releases to your platform, because yeah, the heavyweight change approval processes are yeah, leading to that the processes are slower, that your batch sizes actually of your features are higher, therefore have more dependencies, and that you have fewer releases than before. All together, you have like this kind of thing. And with each change, you obviously have more or potential impact. Um, Additionally to that is that when you have something like yeah, downtime in the past, or when the downtime occurs, that some companies responding to this problem by adding new processes or approval steps into your processes, which actually versus this problem um, So yeah, that's one thing. So never change a running system to avoid downtimes is something you should avoid when you try to involve your Kubernetes DNA. Instead, you should actively manage risk and change more often, or you actively have to manage risk, obviously, and you have to change more often because with each step, um, yeah, we need to have faster feedback. For example, we need better information flow, we need better outcomes, and we need to change more often to maintain stability. Because with each step, we are more or we are better in learning out of the downtimes. For example, when the change has downtimes, and we actually see that when you change more often, your change failure rate is reducing at the same time. So what needs to be done? Yeah, obviously you have some kind of shift left kind of thing there that you embed all the approvals, for example, or requirements, because external requirements or regulations are still in place. You cannot change them most of the time. So you have to embed them into your processes. For example, you can use peer reviews, for example, based as a peer reviews approvals in with the or in your team. You can use infrastructure as code, for example, to automate stuff. GitOps approaches can help you a lot, and stuff like that. So we can embed those things more into the processes on the one side, one side, sorry. And obviously, we need clear processes within the team so that they know, okay, what have we or what do we need to do to get yeah, a release from to done. So the steps has to be clear. So what I really like to think about is when you have a platform team or a cloud native platform, for example, that you think about it as a race car. The race car, yeah, it's set up, it's built mostly out of components that are there at the market or from constructors. They're all the same when you have the when you have Formula One, for example. And the main goal is that you have to be the fastest, but not at all costs, because at some point you have also finished the race. So it's not good when your race car is crashing, for example, or have some failures, because that would losing your points, and that would also lose you the construction title, for example. So think about the platform as a race car, and think about the engineers as the boxing crew, for example, and the developers as the driver. So because everything the construction, the engineers do is how can we do, or how can we enable the driver to drive faster than before, and more safely, obviously, because nobody wants that driver when it crashes. So it combines actually the stability and the speed. So I think that's a good example. Also, we have the constant change with it, because I don't know, most of the parts are there already, but the differentiator is the kind of the configuration you have. So this configuration needs to be done fast, mostly until the next race, or even within the race. Sometimes you only have tiny changes, which makes the difference. For example, yeah, just adjusting the flow, the airflow from the car, because by fixing yeah, the front wings, for example. And also we have complexity, because yeah, changing the angle of the wing, the front wing, might also have influence on the oil consumption, for example, and stuff like that. The second aspect is that everything we do here is a team effort and has shared responsibility. So it's cross-functional. We have engineers who are specialized on tires. We have engineers who are specialized on airflow. We have engineers who are specialized on the weight, for example, and stuff like that. So we have yeah, a cross-functional team working on this platform. And by cross-functional, I also mean the developer, because in the Formula One, the driver is always in the loop with all these changes. He's having requests, he has demands on how he thinks he might be better in the car and what needs to be done. So the team works really close to the driver to have the ideal configuration of your car. And the last one is that we have clear processes. So everybody knows what to do. For example, when you have a pit stop, it does take you like 2 seconds to change all the tires. So the processes are really clear, and that needs to be done also in the platform team, that you have clear processes, or everybody knows what to do when we have a release, when we have a downtime, etc. So what we need to do, obviously, is that we build and automate, not only the incident processes, but also change processes to avoid incidents in the first place, and that we design them, making them fast, reliable, repeatable, and audible. Like in this example with the race car. What we also see is, I showed you the example of the elite performance and the low performance before, that we are, as an elite performer, are better in deployment frequency, so we are more able to deploy more often. Then we are faster in deploying stuff than low performers, and we have a better change failure rate. So changes to our platform are few, and we have a better mean time to restore. So in case we have a downtime, we have a service failure, stuff like that, we are better than low performers. And what is the differentiator in those high performer or elite performer is that they have a culture of optimizing information flow, trust, innovation, and risk sharing. And the risk sharing is something I really like, is that, okay, that pays into these, okay, we have to deploy more often, we have to change more often than before to maintain stability, actually, to keep our platform up to date, to mitigate potential flaws into our platform. At GiantSwarm, we see that, or we define incident handling, for example. So the whole process, we define them in 3 phases, and this also includes changes as well. And those 3 phases are preventive maintenance, the situation we are in the event of an incident, and the incident aftermath. So those are best practices we use, we like to share, and the preventive maintenance, for example, is everything we can do to avoid failures from our platform. Obviously, our KPI or a good KPI is our availability from the platform. So the better the availability is, the better are we in preventing or preventive maintenance, and the change failure rate. So how good are we in changing our system continuously, so that we are not running into any downtimes there. The second one is the event of an incident. Obviously, the one KPI you have to watch there is the mean time to restore. So you have an incident, how good are you to respond to it and to maintain or to restore your service again? And then we have the incident aftermath, which is kind of important, actually, is how good are we to learn from such incidents, and how can we embed this learning into our platform again by automation, observability, alerting, and stuff like that. So a good measurement would be how is our lead time, our lead time in changes. So how good are we to identify lessons learned and then implement them into our platform. So this is one KPI, and obviously deployment frequency. So how often do we do this? Because the faster we are and the more often we do it, the better or the more stable our platform is. To give you some insights, I brought some bullet points here for the preventive maintenance, for example. So best practices we do is obviously we try to have a resilient infrastructure and try to ensure that all the open source components we use on this platform or for the platform are interacting smoothly. So this also means that we don't use don't always use the highest, the newest tool, for example, for any solutions, because we really have a focus on it that it's production ready, for example, or have a maturity that can be production ready. So yeah, we are constantly reviewing our infrastructure, trying new tools, changing tools, adopting tools and stuff like that, so that our infrastructure is resilient. The second one is infrastructure testing. So yeah, obviously you have to test your infrastructure with each deployment or while you deploy stuff. You can do this with GitOps, for example, so that your infrastructure is tested. For releases, you can embed regulations, for example, security policies and stuff like that, so that you are getting the direct feedback if something is wrong or not, or something is okay or not as a platform engineer, for example. And obviously this decreases your change failure rate while updating a platform. The third one is, yeah, automation. Anything that you are doing manually has to be reduced. So reduce your operational toil. Always try to automate your stuff. For example, with GitOps approaches, scripting, infrastructure as code, you name it. And yeah, observability is a big part, obviously, that we are able to ensure ensure that we are identify incidents early. With early, I mean like there might be an incident in the future because of X, Y, Z. That you are seeing signs of incidents before incidents are happening. So this might be, I don't know, the cluster RAM is increasing faster than before, or it might be a full or you might be out of storage, for example, in the future. And so that you have to, or the possibility to react before incidents actually happen. And then the last one is processes. I mentioned before, everybody has to know what to do in before incidents, while changing, for example, but also during incidences. So what is the process when you have a downtime? So you have to train yourself for the worst case scenario. So you have to do fire drills, for example. You have to do chaos engineering, for example, to sometimes just break a cluster and see where it's going, so that you are able to fix things fast and you are prepared to it, like a firefighter. The second phase is the event of an incident. So yeah, incidents, you cannot avoid incidences all the time. That's not possible, but you can prepare for it, obviously. So and you can have things in place when you're in this incident or downtime actually happens. So the first thing is obviously alerting. So set up your alerting system and make sure that the right information to the right at the right time gets to the right person or people. And this has to be improved continuously, actually. So, but I'm talking about this in the next phase. The second one is swarming. So I said the cross-functional situation for the cross-functional situation for the race car is actually also when you have an incident. So swarm when you have an incident and find a solution together. Doesn't help if the platform team says, okay, yeah, it might be the application, and the application team say, yeah, but I think it's the platform. So sit together, swarm, and find a solution together, because at the end you're sitting in the same race car, or the goal is that the race car is not crashing. So find a solution together. Then the third one is access. So make sure that application teams are able to access critical log files, for example, for their own issue handling. So every access they need in order to handle issues is helpful and is helping you as a platform team not to have too many firefights. And the last one is hotfixes. Yeah, sometimes you cannot identify the root cause. Sometimes yeah, Kubernetes or the platform has some twists. You have to be prepared for that, and sometimes hotfixes might help. Make sure that you have ops recipes in place or runbooks in place to just identify or give a solution for common errors and common errors and have a hotfix there. And the last phase is the incident aftermath. It's when a downtime happens, you should always have a lesson learned out of it. So the lesson learned you can receive by postmortems, for example. So sit together after an incident with the application team, for example, the incident occurred or the service occurred and talk about and identify how you can grow your operational capabilities. This part is often missed in companies that you have to tidy up the stuff. Obviously, you want to have the downtime fixed, and then everybody's okay for the most of the companies. But in this particular thing, you have really think about, okay, how can we improve out of it? And yeah, programmatic changes. So root causes must be identified, and when you have identified the root causes, you have to embed it into your automation, in your alerting system, in your monitoring, and also in your scripts and stuff like that, in your run books, for example. And this must be ideally the solution is automated so that you don't have to worry about it in the future anymore. And the last one is iterating. You have to iterate your platform continuously. You have to change frequently so that downtimes might not occur, because the worst thing is that downtime happens because some versions are not matching anymore because they're outdated or something like that. So that's the worst case scenario, because it's just you can avoid it. So the bottom line is that for your platform DNA, for your Kubernetes platform DNA, you have to accept that change is always a part from the platform team's responsibility in order to reduce impact and incidents. Change has to be part of the DNA. Has to be part of the DNA. You have to change more frequently, and what about you have to change more frequently, because in the past or the current or most of the time the mindset is, okay, we want to avoid change in order to reduce risk. No, the thing is you have to change in order to manage risk. That's the bottom line here as well. Okay, so the question is, why our platform teams struggle, and I have a poll prepared for this as well, and sharing it right now. And the question is, what are your biggest challenge when it comes to changes and stability or stability? And you have like five options to choose from. I just let you some time to answer the question. Okay, so one challenge we see is that when you're starting or your cloud native journey, or you're already on your track of the cloud native journey, that dependencies within the existing organization might block your team. So we have usually we have something like this. We have a corporate IT developing solutions for sales, e-commerce, business, or the corporate itself. We have the IT operations where we have service coordination, infrastructure, workplaces, and we have the IT security. As a, yeah, in Germany we call it Stabsstelle. Well, and we have governance and compliance. So the problem here is that, yeah, I don't know, business is demanding cloud native services, for example, and the IT operation says, okay, we need to handle this. Okay, let's start a small team of a platform team, and then let's go. The problem here is that this doesn't work because everybody here has different priorities, different goals, and when the cloud native team is trying to develop something, they're always depending on, for example, IT infrastructure or IT security, for example. So we have like prioritization conflicts here, which is slowing us down. We are waiting. We're waiting for information. We are waiting for something to be done or concepts or something like that. And here's the lesson learned, or the thing that we see is that when you're trying or when you want to do cloud native, go all in and have a holistic, comprehensive cloud native strategy for the whole company so that you don't leave your cloud native team, your platform team alone. The second one is, island of automation might increase complexity and toil. This might happen because we have new tools, for example, but haven't or weren't able to automate or integrate older tools the proper way. This might also happen because, for example, business units are starting to do their own services. They're starting to use cloud by themselves and then say, okay, we have a cloud solution here for our use case. Are you able to operate it? And those island of automation increases complexity, and the team is handling too much at the same time with the resources they have. And obviously that's challenging to release new features, to innovate faster, and on the long term, obviously, to maintain stability. So the lessons learned here is that obviously you need a clear cloud native strategy, but also have to think about your platform and your platform team as a product team. And the product team has stakeholders, and they have to actively manage their stakeholders and their demands in order to increase, improve their platform, to scale their platform on the long term. Then, unplanned tasks might interrupt development. This is something designed because the platform team is always having incidents, for example, or issues or questions. And at the end, you want to, or you have a project you want to do, you have new features you want to release, but they always get interrupted by unplanned tasks. This also can be handled by stakeholder management, obviously, and clear communication between the teams. And but this is kind of tricky. There's no right lessons learned here. Only the one thing is that please avoid ticket handling in this kind of scenario and have direct communication with your developers, with your application teams, because ticket handling leads to waste in order to waste information loss, and is a process overhead. So this might be a lessons learned here. And obviously one blocker is that the team might be understaffed and is the bottleneck. That's no surprise actually, because when you have like, I don't know, 5, 6 application teams demanding having requests to your team, this might be just too much work for your team. Also, it's really hard to get expertise on the market for cloud native at the moment. So this might be also a problem. But we see that when you have the right strategy in place, when you have the processes in place, that it might be able to handle this bottleneck as well. And yeah, the last one is technical debt might be slowing you down, slow down your feature releases. So when you're starting or setting up your platform, the demand might be that high that you try to save time by setting up a platform with the technical debt. Technical debt itself is not the problem because agile development you always think about okay, how much technical debt can I do in order to be faster? How much is it? How much I'm trying to receive, or in order to be faster. So how much technical debt I'm willing to pay. So I'm willing to pay to be faster. This is not the problem. The problem is that by the demand overflow, people sometimes or platform teams sometimes receive is that you are not able to fix those technical debts or reduce those technical debts on the long term. So you have at some point you're building your platform on an unstable situation, and this is something critical. So when you have this scenario, the lessons learned is sorry, that you obviously have to reduce the technical debt. Don't do too much at the same time. Try to do one thing at a time in order in your roadmap, for example, and do it right, I would say. So reduce your VIP limit is here the main message that you have, or you're not drowning in technical debts in the future. So summarized, how can you enable your platform is that obviously you have or you should have a platform strategy. The platform strategy must be thought of a holistic across the entire organization, so everybody has the same goal or is at least committed to the cloud native journey at some place, at some point. So that might be as simple as, okay, we have a legacy data center, for example, and we want to go cloud native. A decision needs to be made. Okay, how much cloud native do we want to do in 2 years? Is it like 20, 30, 40% of our workloads compared to our on-premise, for example? So those decisions has to be made so everybody has a clear idea of where this journey has to go. Then you need independent teams, preferable cross-functional. So they have to act independently as much as possible. So everything you do, process-wise, organization-wise, think about how can we do independent teams. This is one not only for the platform team, but also for application teams and stuff like that. This is this is accelerating your teams in releasing features, in preventing downtimes, and in fixing them really fast. And the third one is lessons learned lessons learned is that that you shouldn't reinvent the wheel. So the primary goal should be that you enable your dev team and not build a cloud native stack. So think about what is enabling our dev teams in order to deploy faster and more often software to production, so that we can create business value more often. So there are some commodity tools, for example, on the market. You can use some managed service providers such as us that you can use to help you with your operational toil. So don't try to save the world by building up your own cloud native stack. You should really think about what you should do by your own and what you shouldn't do by your own. For example, setting up clusters can be automated and has been automated from several service providers. Platform or the fourth lessons learned is that you should see your platform as a product. So the product needs to have a product owner and a clear roadmap, which is agreed on or committed by every part of the organization. So everybody knows what the next steps are for your platform. So this is for transparency purposes, this is for visibility and most importantly for structure for your team, so that they're not drowning in requests all the time and they don't know what to do next. So this is really important. And also important is that you have an MVP approach, that you don't try to implement the most exotic use case at the first try. So what we also see is that, okay, we have these use cases and there are regulations in this case, in this case, in this case. Start with an easy one so that your teams are so that your teams can adapt to the processes, so that you have time to reduce technical debts on the long term, and that you can figure out how to handle your organization processes. For example, do we need to change them? How can we help our team to be more independent in the future and stuff like that? And the last one is iterate, iterate, iterate. It's a journey, and the platform is in constant change, as mentioned before. So how can GiantSwarm support your platform team? So this is some advertisement from our side, from my side, how we can help you. So GiantSwarm offers a solid open source platform. We set them up from different kind of open source tools. We make sure that everything is open source, and we make sure that it's stable and tested and working great together. We have a lot of experience in this field. So we have been doing we have been doing this for a long time, and that's why we can say, okay, our platform is stable and can provide benefit for our customers. The second one is that we are extending your SRE team by helping you by managing this for you, the platform. So the basic platform stuff we can do for you. For example, setting up the platform, then configuring API gateways, setting up security policies and stuff like that. So we can do this for you, so you can focus on innovating your platform. Innovate your platform and reduce your operational toil. We can help you there. And also we have, for example, no ticket handlings. You have a direct Slack channel to our SRE teams, so that when you have a question, when you have an issue or something like that, that you can always reach out to us via Slack, and you get help immediately. So it feels like that we are sitting next to your table and helping you on your journey. Then the third one is coaching. So we can help you with the strategy, for example. We can help you with the processes you have to think about, run books, stuff like that. And we can really coach you in, okay, how should your team, but also your company evolve in the future in order to accelerate your cloud native journey, in order to gain more business value in the future by deploying, implementing features faster and more often than before. And obviously we have lightweighted processes in place, so everything we do is automated and also embedded in our processes. And when you ask us and need our help, we can identify the processes and help you there as well. And the last one, the most importantly, is the hive mind, I guess, because we have several customers, and every issue they might have or might not have, we can identify and make sure that that when a customer has an incident, for example, minor, major incident, doesn't matter, and that we implement it into our platform concept, that we do an upgrade so that you receive the upgrades as well, so that nobody has to run into the same issue again when somebody has already run into it. So we make sure that we have this hive mind in place so that we don't learn from the customer individually, and then we extend those learnings to all customers at the same time. That's a quite a good big benefit there. Yeah, and the last one, the last page actually, then I'm ready. I'm done. Looking at the clock, we have 12 o'clock already. This is a informational slide on our setup and how we can provide help you on the that you have a dedicated platform, for example, and that you have different infrastructures and stuff like that. So bottom line, we support your teams beyond traditional ticket handling. We involve you together. We are one team, one platform, one SRE, and always have the race car in mind. So we help you to become this race car. So thank you all for listening, and that's it.